In this example, we're going to look at what a point is. The question we're going to ask is, what is a point? So right now, off the bat, we're staring at something, and it's a big red dot. My question to you is this a point? It looks like a really, really big circle. Well, let's investigate further. It's a very large point, but can the point become smaller? Well, the reality is yes. We can have a point like this. We can have one this big, this big, this big. We can get to the point, no pun intended, where it's so small we can barely see it. Is it still a point? Yes. The real question is, can it get smaller than that? And of course it can, right? Well, how small is a point? The reality is a point can be as small as it possibly can be. But how small is that? So how small is an actual point? And what is a point, really? I mean, we started out with this really, really big, massive thing, and we got all the way down to something that we could barely see. So, if you can't see it, is it still a point? Well, yes, of course. You could take a microscope and zoom in and then still see it. So, what is it? Let's go ahead and read this together. It says, in reality, a point is infinitesimally small. In other words, a point is so small that it actually has zero size or shape. Anything bigger is technically a circle. So, a point is actually a location in space. A lot of times in order to imagine it, we have to actually draw it, like this point right here. We can see it clearly. But the center of that point itself, in other words, the dot in the middle of that, whatever that location is what the actual point is. So it's a location. We draw something to visualize it, but in reality, it doesn't have a size. It's just a location. For example, if you said you lived 30 degrees north of the equator and 80 degrees west, whatever that location would be, that's a point on the earth, right? Is there an actual physical place? Yes, you could go there, but that actual place on the earth doesn't have a size or shape. The actual location is just an idea. It's relative, actually, to another point on the earth. We draw points only to visualize their location. The location of a point depends entirely on its surroundings. So let's take a look. Let's say you're looking at a point. The center of the red ball, which is a point, is 10 feet to the right of your eye and 2 feet above it. Okay, so that's one way to describe a point. For instance, if you're looking at the sun, you could say the sun is some horizontal distance away from you and some vertical distance. Of course, it'd be a massive one. But basically, what we're seeing here is a point has a location. Okay, it would be a point. Suppose your eye is at the point 0, 0. Okay, and it is the starting point. Then the center of the red ball would be 10, 2. In other words, we can label that point. I'm not sure why I didn't label it before. 10, 2. Why? Because that point is 10 feet horizontally from your eye and 2 feet up. Then the center of the red ball is 10, 2. The 10 represents the horizontal distance from your right eye, and the 2 represents the vertical distance from your right eye. So a point is merely a location. We draw something there so we can see it, but think about this. Even if we didn't draw that there, okay? If we drew nothing there, the point would still be there, right? It's just we drew something there to mark that it was there. So what is the point? Is it what we draw, or is it an idea? And the point is, no pun intended, a point is an idea. It's a location. It depends on, it's relative to something else. René Descartes developed a simple system of plot points, among other things. It's called the Cartesian plane. Okay, it's called the Cartesian plane. It's named after him, because his last name is Descartes, and you can see part of his name in that. The center of the graph is 0, 0, and it has 4 quadrants for reference. So the quadrants are 1, 2, 3, and 4. Now, I don't know exactly why we chose that. I mean, I do know that the quadrant 1 is the most, I don't want to say the most popular, the most used maybe, because all the values are positive. And then you actually go counterclockwise to get to the next quadrant, which is quadrant 2. Counterclockwise again to the third quadrant. All the values are negative in that quadrant. And then counterclockwise again to 4. And then you go counterclockwise again and you're back at the first quadrant. So let's go ahead and do some examples where we just graph some points. Let's go ahead and graph the point 4, 7. I'm going to put it back on the origin just in case I go through this lesson again, but we want to graph the point 4, 7. Well, you always plot the, and we're going to ask what quadrant it is. You always plot the x value first. Alright, so we're going to go ahead and look at where x equals 4, and that's right here. Okay. And then you go up to the particular y value. So this means the y value is 7. In fact, I can sometimes helps if we label these. That would be x and that would be y. So now we've gone to x equals 4. Let's see where y equals 7. If I put this right here, and for some reason these x's aren't labeled, so I'll go ahead and label them. This is the x-axis and this is the y-axis. So here we have x equals 4, here we have y equals 7. We want to put a point where those two intersect. It'd be right there. And the question asks what quadrant this is in. Well, it's in the first quadrant, right? It's where all the values are positive. So we have a coordinate system that all starts at the origin. Okay, it all starts at 0, 0. And from there we can plot any point, and it's relative to the middle, right? It's relative to 0, 0. Now again, we plot the point, but it's still just a location. I mean, even if we didn't plot it, it would still be there, right? There'd still be a 4, 7. We just notate that, letting us know that, yes, that's where the point is, 4, 7. Next, we're going to graph the point -3, 6. -3, 6. So again, let's go over to the x value, -3. I almost went to +3. So here's my x, here's my y. I'm going to go over to -3 on the x-axis. Again, this is the x-axis, and this is the y-axis, in case you didn't know. And then I'm going to circle where y equals 6, which is going to be up here. And here's one way to do it. You can kind of see that we plot the point where if we draw a vertical line from x equals -3, we must draw a horizontal line from y equals 6. We're going to plot our point where those two intersect, which would be right there. So when you're first plotting points, that might be helpful to draw those two lines to help you plot that actual point. But again, you know, the point itself was there before we put our dot there. So a point is actually not a dot. The dot represents where the point is. It's pretty crazy. And this actually makes me think of something even more philosophical. How small can something be? You know, in other words, if going back to, well, actually, just thinking about matter in general, you know, let's say that the cell is the smallest thing possible. Well, we already know that there's smaller things than that, electrons, protons, even things called quarks, and things smaller than that I'm not even sure about. But like, the reality is, you know, I wonder sometimes what's in the very, very middle of all of that. You know, I don't know, but it's interesting to think about. And it correlates to this lesson, which is what is a point, how small is it? It's just a location. I guess the reality is we think something's there, we just don't know what it is. Anyway, what quadrant is this in? This would be the second quadrant, just to the left of the first. Example 3, let's plot 5, -4. Okay, so again, we can label this x and y. Let's not forget to label our graph. That's y, and that's x. Okay, so for the x value of 5, we're going to circle right here because that's where x equals 5. For the y value of -4, circle this. Again, we can draw two lines to where these two things intersect, and they'll help us know that's where that point is. So the point 5, -4 is right there. And this is actually in the fourth quadrant, right? And that is when the x value is positive, the y value is negative. Sometimes you can plot you can plot decimals. Let's see how to do that. Okay, so again, this is our x value, this is our y value. I'm going to plot -6.5, -1. So -6.5 is going to be somewhere between -6 and -7. I'm just going to kind of put like a little point right here. Just that's not the actual point we're plotting. Actually, I'll put one right here. So somewhere about right there is negative 6.5. And then negative 1, you know, we can certainly circle, is going to be right here for y. Oops, I didn't circle the actual number. Okay. So we want to figure out where these two cross. So it would be right here, negative 6.5 comma negative 1. This is where our point's going to go. And there we have it. Negative 6.5 comma negative 1. And sometimes, you know, if you want, you can go and label these points just so you know exactly where you're at. Negative 6.5 comma negative 1. And furthermore, we're going to ask where is, which quadrant is this in? This would be in the third quadrant. Again, the third quadrant is where both the x and y values are negative. You can see that here. But again, let's make sure and label our axes, however you want to say it, x and y. Okay, and you know, sometimes you can plot 2 points on the same graph. We're going to do this quickly. 3, 4 would be, here's x equals 3, here's y equals 4, so it's going to go right here. And 8 comma 0, so 8 comma 0. 8 comma 0, here's your x value. And so we can see the 8, I might move a little bit up. But there's 8 comma 0, there's your x value. Since your y value is 0, you don't go up or down. Okay, you keep it right on the y-axis, so that's 8 comma 0. What quadrants are they in? Well, we'll just label it on the actual graph. This one is in the first quadrant. However, this point right here, 8 comma 0, is not in a quadrant. It's on an axis. It's on the x-axis. So if a point is on an axis, it's not part of a quadrant. You can just say it's on the x-axis. Okay, so 8, 0 is on the x-axis. That's all I need to say about that. Finally, last example, we have negative 7 comma negative 2.5 and negative 2 comma 1.5. Just want you to be more comfortable with plotting decimals. So the first point, again, this is y, this is x. First point is x value is negative 7, y value is negative 2.5. That's going to go right here. Okay, it's in between negative 2 and negative 3 for y value and negative 7 for x. Hence negative 7, negative 2.5. The other point, negative 2, 1.5. Negative 2 comma positive 1.5. Okay, going to be right here. So again, the x value is negative 2, the y value is negative 1.5, and that comes right here. And I think this asks which quadrants they are in, so this one up here is in the second quadrant, and this one is in the third. By the way, just throwing this out there, I'm just going to add a third point on here. What if we wanted to plot the point, say, 0 comma 6? Okay, and ask what that quadrant that's in. 0 comma 6 is going to go right here. I'm just using my finger to plot that, and again, that is not in a quadrant. It's not in a quadrant because it's on the y-axis. And so how do we know to plot on the y-axis? Well, x is 0, so notice for the x value 0, it's in between negative 1 and 1. The y value is 6, and that's on the y-axis. So that's it. That covers the lesson on what is a point and how to graph it. If you have any other questions about that, let me know.